Hello and welcome to another lesson of this series titled Building Secure, Scalable, Fault-Tolerant and Low Latency APIs with Java and Spring Boot. My name is Ngane Emmanuel and this particular lesson is focused on authorization and access control. That is controlling who can do what in your API. So if you've been following our series with the last couple of videos, we already went through the life cycle of a request. We saw authentication and where it's implemented using filters, and we're supposed to look at interceptors, and that is where authorization is usually implemented in Spring Boot. And basically all of these, again, just to recap, is part of the middleware, and we are trying to I'm trying to give you a proper understanding of authorization if you have not. So let's dive right in, but before we do, I need you to like, share and subscribe to the channel. Click the notification bell to get updates when I upload new videos, and also comment your questions and your worries below in the comment section. And the relevant resources such as the link to the repository of this video and the link to my social media in the description below. I will be happy to connect with you and discuss more. That said, let's continue. Right. So let's look at authorization. So why authorization matters? You see, authentication verifies identity, authorization controls permissions, right? And a secure system must ensure users can only access what they are allowed to, privileged operations are protected, and data exposure is minimized. Again, just a few recap. These tutorials, usually the ones that you see, most of them are slides. They are pretty much detailed, and I'm just going to read through it and explain additional give additional explanation of where I think is necessary. But again, if you are not satisfied, you can always Google and also ask me in the comment below. So and the practicals will follow this video. So let's continue. So by the end of this lesson, you should be able to understand authorization concepts, learn access control models, identify common vulnerabilities, design secure permission systems, and prepare for Spring security implementation, continuation at least. So what is authorization? Authorization determines what actions an authenticated user is allowed to perform. It answers the question, what can this user do? Authorization is different from authentication is such. Authentication asks who are you, authorization asks what can you access. And authorization always happens after authentication. Very important. You authenticate first before you authorize. Now, there are different ways of implementing authorizations, and we're going to be looking at some of them. Okay. So let's look at different authorization principles such as permissions. A permission represents an allowed action. Example, read user, create order, delete product. And permissions are fine-grained. You can also regard them as policies. Roles on the other hand are groups of permissions. Example, admin will have a group of permission. User support will also have a group of actions that they want to be able to perform, which are governed by permissions or policies and so on, including support. Roles simplifies management. Role example, like I said, admin, create user, delete user, view, report. These are the actions an admin can perform. A user can maybe perform your site, view profile and create order, and so on. So there are different kind of access control models, and let us review some of them. The first one, we're going to look at role-based access control model, which is also known, abbreviation is RBAC. So you've probably heard of this before. And in this case, users are assigned roles, and roles grant permissions. Simple and widely used. The second one is called attribute-based access control, ABAC. They are decisions based on attributes. For example, user attributes, resource attributes, environment conditions. More flexible but more complex. And the last one is called policy-based access control. These are centralized policies define access rule. These centralized policies define access rules used in large distributed systems. For example, those of you who have used cloud systems like AWS, if you go to the IAM section, then you have policies there. So it's very important. Those are probably the two most widely used access and policies that we have. So let's continue. Where authorization happens. Where does authorization happens? The API layers. Authorization should occur at the controller level. Well, yes. So first of all, I made this slide because I wanted to link it to. I made this slide a long time, so I wanted to link it to interceptors. But yes, this is correct, right? Authorization occurs at the controller level. Technically, well, before them, in this case, interceptor. So I am sorry for this. But at the interceptor level, which you see me explain, you intercept the request before you get to the controller and you perform section-based authorization. Okay, so basically at the endpoint protection, you can annotate a particular endpoint with a particular annotation, and then you intercept the request and read it. So it is correct, but the implementation, it combines with the interceptors. So it's also happens at the service level. Yes, this method level protection, where you have the same implementation with the controllers, and sometimes at the database levels. Yes, also again same ideas where you do read and write policies, and you protect the action based on the available authorized policies that the user has. Again, you're going to see a demo in the practical session that is following this video. So again, this is all correct, but you get more understanding on why I talk about interceptors and how they work with authorization. So yeah. So common authorization vulnerabilities for one is called broken access control. In this case, user access resources they should not. For example, accesses another user data, calling admin endpoints. And in this case, usually this is when you're not checking ownership. I mentioned in I think one of our videos about ownership check, that you don't just check for whether or not you can access, you also check ownership, whether or not you own the data that's been accessed and something like that. And this particular broken access control usually comes with wrong logic implementation and assumptions, right? Again, insecure data object references manipulate IDs in URLs to access unauthorized data. Again, something like this, right? So this is not being verified and stuff like that. So this is an example of it. So maybe you were supposed to only have access to this, and then you change it to 1, 2, 3, 4, and then you have access to it. Again, this you have to. It's almost, I think it's still the same thing as this one, but insecure direct object reference could also binding object directly, right, without verification and validation. So, and overprivileged roles, user receive more permission than needed. So in your roles, you have, so because like I said, if you look at roles, right, these are roles, and each individual action is policies. And say for user, you add create user. A user should not be able to create a new user, right? Then that's an overprivileged role that you have created and attributed to a particular user. So basically, you are going with the principle of least privilege, right? So violates the least privilege principle. There we go. So authorization best practices will include enforcing least privilege. This is the primary. You want to make sure that every user or entity in your system just has the exact privileges they need to perform their given actions and their given responsibilities. Nothing more than that. Okay. So you validate ownership. I just spoke about this. You don't just validate whether or not you have the role that is required to access it. You validate whether or not you have, whether or not it is your data. If in the case, for example, it's a user, but it's a user information data, are you the user and you have, is it your data that you're trying to access, not that do you have maybe a user role that allows you to access a particular data? You get, because you can't definitely implement a system that checks whether or not a user can access a particular role, or maybe an employee can access a particular user. But then, can an employee access another employee, or let me just say a common employee, not maybe a manager, access another employee's data? Then you don't want certain things like that, and this you can have this implementation in users, right? And so you want to check for ownership. For example, the ID is the verified user, and the user are the user context. The ID that is there, is it equal to the ID of the data of that user data, right? To make sure that this user is the same user, that is the same this user, this is the information that belongs to this particular user that this user is trying to access. And that's the whole idea. So you have to use centralized policies. Again, you have to make sure that your policy designs are basically centralized. And we'll see this in the coming videos, not basically in video. I think by the end of all of this security, I would design a full scale policy-based security system for authentication and authorization, something similar to use knowledge from like Amazon to protect against resources and users. And we're going to look at that. And log authorization failures. So when something goes wrong, you want to make sure that you log it. This is for security audit and for later verification. So perform regular audits. Again, same thing. Design for scalability, right? So these are common best practices. You have to design for scalability, and that means you have to look at future growth, right? So authorization system must support new rules. You don't want to make sure that when you design your system, you cannot add new rules, right? Or maybe you add a new rule and everything else breaks, right? So you have to be able to support new rules, extendable, and support new permissions, avoid hard-coded logic, okay, and design early. So there we go. So you are going to see in this avoid hard-coded logic when checking for role-based access control. When I'm looking at when I am going to be doing with interceptors, you're going to see first implementation where it's a bit tight, right? The first implementation is tight, then I later on show you, well, at least because I already implemented, I'll show you another implementation that allows you to pass that allows you to use it across multiple scenarios, and it is easier to use, right? You're going to look at this all. Practical implementation. So this is what we are going to be doing next. Role-based access in Spring Boot, right? Protect endpoints and demonstrate this attack, right? So apply fixes. And that's basically all of it. It's a very short one, so not too long. And it's just part of the security system that we're talking about. And I just wanted to make a very quick video to give you a head start understanding about rules and access that you might find interesting. That said, I hope this video has been very helpful, informative, and captures everything about authorization, and it flows fluently from the authentication and the practicals we've seen. So we are going to look at authorization practicals, implementation using interceptors, and we're going to also look at method level validation in the video that's going to be proceeding, the one we're making after this. So that said, thank you for watching, thank you for staying tuned, like, share, subscribe, and again, I appreciate your comments, I appreciate your reaching out, it's been helpful, and see you in the next video. Stay well.